Okay, so this is 4.5 part 2. It was just a good place to break the video. All right, so what we're going to talk about now is using zeros to write a function. The most important thing on this video is that we talk about the irrational conjugates theorem. So basically, what it says is that if we have a zero in the format a plus the square root of b, then even if they don't say we have another zero, we know we have to have another one that is a minus the square root of b. Now let's see that in action so it'll make more sense. So example 3 says it gives us the zeros and we're writing the polynomial function. So it says write a polynomial function f of least degree. What that means is the lowest degree possible, because if you had repeated zeros that have multiplicities, then you could get, a very high degree. If you say had a zero show up 3 or 4 times, that was the same zero. So that's what they mean by least degree, is no multiplicities or no repeated zeros. It has rational coefficients. It has a leading coefficient of 1. That's important because that tells us what our leading term is. So we won't have to multiply through by a different number. 1 is very basic. Now here we have one of the zeros is 3. So that right there tells me that I have a factor that is x minus 3, because that is the factor that gives me a 0 of 3. Now another 0 is 2 plus the square root of 5, which tells me automatically there's also, based on the irrational conjugates theorem, there's also another 0. If you have 2 plus square root of 5, there has to be one that is also 2 minus square root of 5. Okay, so now let's look at how to make those zeros be factors. So what we're going to do is 2 plus square root of 5, we're going to write it as x minus 2 plus square root of 5. Go ahead and put it in parentheses. So it's just like when the 0 was 3, we wrote x minus 3. Well, when the 0 is 2 plus square root of 5, you write x minus that 0. And then also, the other one is x minus 2, and then, minus square root of 5. So I'm taking the zeros, and I'm turning them into factors. So basically, right here, this whole list, these are now my factors. Okay, now the hard part is taking this and turning them into a polynomial. It's not too bad, it's just a little bit of work. So I can start out and I can say, well, my function is x minus 3 times, now I'm going to take this factor right here, this x minus, and then the 2 plus square root of 5, and I'm going to distribute the subtraction sign. So that's going to become x minus 2 minus square root 5. And then I'm going to do the same thing over here to this factor. I'm going to distribute this subtraction sign through to the 2 minus square root 5. So that becomes x minus 2 plus square root 5. Okay, so now to get it to be a polynomial, we need to multiply it out. So what you're going to want to do is you're always going to want to multiply the two factors that used your zeros, 2 plus square root 5 and 2 minus square root 5. Multiply those first. There's different methods of multiplying, but personally, I like to just step out to the side and use our area model or a box method, whichever name you prefer. So there are 3 terms in each one, so that's why I set my box up this way. The first one is x minus 2 minus the square root of 5, and the second factor is x minus 2 plus square root of 5. Okay, so this first box is x times x, that's x squared. X times negative 2 is negative 2x. X times negative square root 5 is negative x square root 5. The next row is negative 2 times x, that's negative 2x. Negative 2 times 2, that's positive 4. Negative 2 times negative square root 5 is a positive 2 square root 5. Okay, this one on this bottom row is x times the square root of 5, that's x square root 5. And then negative 2 times the square root of 5 is just negative 2 square root 5. And now this is a little funky. When you have negative square root 5, fell off the page here. Negative square root 5 times positive square root 5, you get a negative and then the square root of 25, which is 5. Okay, it's going to work out like that every time. Now, some things are going to cancel out. Your x square root 5 and your negative x square root 5 make 0. That's why I crossed them out. And your 2 square root 5 and your negative 2 square root 5 make 0. So what we have here is we have x squared You see right here we have our minus 2x and minus 2x. That makes minus 4x. And then you see also we have our 4 and our minus 5. And 4 minus 5 is negative 1. Okay, and so that's the solution when I multiply those two highlighted factors. Now we need to multiply the remaining two factors, x minus 3 times x squared minus 4x minus 1. So once again, what I'm going to do is I'm going to use the area model. All right, so we get it set up here. So I have x minus 3 and x squared minus 4x minus 1. All right, so what I'm going to get is x cubed minus 4x squared minus x minus 3x squared plus 12x plus 3. So that means that f of x will be, when I combine like terms, x cubed. I can combine this minus 3x squared minus 4x squared. So that is going to be minus 7x squared. I can also combine this minus x plus 12x. So that's going to be plus 11x and then plus 3. And that is a polynomial written out in standard form that has a leading coefficient of 1. It's the lowest degree possible, and it has the zeros of 3 and of 2 plus square root 5. And because it had 2 plus square root 5, it also has a 0 of 2 minus square root 5. So if that was a little overwhelming, you're completely okay. It's hard the first time, but then you start to see a pattern to it. So let's go ahead and try another one. All right, so this says write a polynomial function f, okay, so it's f of x, of least degrees. So that tells me, when it says least degree, that tells me there's no repeated zeros, no multiplicities. It has a leading coefficient of 1. Good to know. Okay, now here's its zeros. It has a 0 of 2. So if the 0 is 2, then the factor is x minus 2. It has another 0 of 3 plus square root 7. So automatically when you see that, I hope you know that it then has another 0, even if it's not written, a 3 minus square root 7, because of the irrational conjugates theorem we learned today. So now, how we write those as factors? X minus the 3 plus square root 7 and x minus the 3 minus square root 7. Okay, so there's our factors. So remember, what we did last time is we set it up to multiply. So f of x equals x minus 2. Now remember, I'm going to take this factor and simplify it a little bit. Sorry, I've got a parentheses there. And I'm going to distribute that negative. So I have x minus 3 minus square root 7. And same thing here, distribute that negative. So it's x minus 3 plus square root 7. Okay, so now you need to first, remember, you're going to multiply the two factors that involve the 3 plus square root 7 and the 3 minus square root 7. So remember, how I'm going to do that is I'm going to jump out to the side and just take my time. And if you recall, last time some things simplified out, they canceled out to 0. And that's going to happen every time. You're going to really start to see some patterns here. Okay, so I'm going to zoom in on this so you can see it just a little bit better. So I have x squared. Remember, I'm multiplying. Minus 3x minus x square root 7 minus 3x plus 9. This is negative 3 times negative square root 7, so it turns into positive 3 square root 7. So then here I have x square root 7, and then negative 3 square root 7, because it's negative 3 times positive square root 7, so that's why it's negative. And then this turns into negative, because it's a negative square root of 7 times a positive, so that's why it's negative. And remember, the square root of 7 times the square root of 7 is just 7. Now, some things are going to cancel out. So this 3 square root 7 and the negative 3 square root 7, those cancel. And the negative x square root 7 and the positive x square root 7. Okay, so now what we're ready for is we are going to go ahead and we're going to combine some like terms. So I have x squared, and then I also have minus 3x minus 3x. So that's how I get minus 6x. And then I also have this plus 9 minus 7. So that gets me positive 2. So I'm going to put plus 2. Okay, so remember, to get to our final step, we now need to multiply the x minus 2 times our new trinomial x squared minus 6x plus 2. So once again, I'm going to use my area model. It helps me not lose any terms. All right, so I get x cubed minus 6x squared plus 2x minus 2x squared plus 12x minus 4. So that turns into x cubed minus 8x squared plus 14x minus 4. And that is our polynomial of the lowest degree possible. It has a leading coefficient of 1, and it has zeros of 2, 3 plus square root 7, and then automatically also 3 minus square root 7. Okay, so this next problem is another practice. So if you need this one, I'm going to go ahead and do it. But if you do not, then you can go ahead and go on to the next video. I've broken it up into 3 parts just to kind of save you guys some time. So if you're still confused, let's do another one. But if not, feel free to stop the video here. All right, so once again, least degree tells me there's no multiplicities, meaning no repeated zeros. Leading coefficient of 1 is nice because it just means I don't have to multiply through with a different number to kind of change the leading coefficient. The zeros are 4, so that tells you you have a factor of x minus 4. One of the zeros is 1 minus the square root of 5, so automatically you should write down, hey, I have another 0 of 1 plus the square root of 5. Okay, let's turn those into factors. So it's x minus the 0, 1 minus square root 5, and x minus this 0, 1 plus square root 5. All right, so remember that to turn those into kind of a simpler form, we're going to distribute the negative. So very similar to what we've done, and there's a lot of patterns here. And then distribute the negative on the other one. So you have x minus 1 minus square root 5. Okay, so remember, when we're simplifying this by multiplying, we're going to multiply here the one that has our irrational number, the square root of 5 in there. Multiply those first. Every time it's going to make your job a lot easier. It would work the other way, but it's going to be a lot messier until it simplifies out at the very end. You're much better off doing it this way. Okay, so I have x minus 1 plus square root of 5, x minus 1 minus square root of 5. Okay, go ahead and multiply. X squared minus x, a positive x squared root of 5, minus x plus 1, because you have negative 1 times negative 1, minus square root of 5. Let's see here. Negative x square root of 5. A negative 1 times the negative square root of 5 is plus square root of 5. And then remember, this one always kind of gets people, the square root of 5 times the negative square root of 5. It's negative, and then square root of 5 times square root of 5 is the same as square root of 5 squared, which is why it just makes 5. Okay, now, as it has in the past, some things are going to cancel out. The negative x square root of 5 plus x square root of 5 makes 0, so it cancels. The square root of 5 minus square root of 5 makes 0, so it cancels. So let's go ahead. I'm going to write our x minus 4. Now let's combine like terms. So I have x squared, and then I have this minus x, that combines to minus 2x. And then this positive 1, minus 5, combines to, negative 4. All right, so to go ahead and to finish this out, we're going to go ahead and we are going to multiply the last one with the box method again. So set it up down here. X minus 4. I need 3 boxes because we have a trinomial, x squared minus 2x minus 4. All right, so that gets me x cubed minus 2x squared minus 4x minus 4x squared plus 8x plus 16. So my polynomial is, when you combine like terms, x cubed minus 6x squared plus 4x plus 16. And that is the solution to that polynomial that has a lowest degree possible, leading coefficient of 1, zeros of 4, 1 minus square root of 5, and 1 plus square root of 5.